There are more than 3 billion cameras in the world, and this is creating an amazing revolution in imaging and visual computing. So my group at MIT Media Lab is pushing the envelope in futuristic technologies and also imaging for social innovation, such as mobile phone diagnostics that in this case can scan prescription for eyeglasses and cataracts, or cameras that can see the world at 1 trillion frames per second to look around corners, and technologies for capturing and sharing the information in 3D. Now, every one of us has intrinsic abilities to invent and solve problems, but the process of invention often seems confusing. And what I have learned is I need a mental framework. If I hear a great idea X, how do I come up with what's next? I call this framework an idea hexagon, and it's all common sense, but you can just apply formulas and come up with dozens of more ideas. So let's start with an example. There's a great opportunity in creating a business, a website, where you can share photos, like Flickr. What would be your next idea? Yes, a website to share videos. We just went in one dimension, the time dimension. Well, Flickr was sold for just a few $1 million, but YouTube was sold to Google for $1.6 billion. This notion of applying and generalizing an idea to another dimension can be very powerful. When we talk about displays, we have gone from 2D to 3D, but that requires these funny glasses. So in our lab, we have invented technologies for glasses-free 3D displays. But it turns out, to do that, you have to create 4D displays. It turns out the appearance of the world is not 3D, but it's actually 4D. And the challenge, of course, is these four-dimensional displays require about 1 terabyte per second of data. And this is going to be quite challenging to feed to the display. So we have created a new compressive display that can reduce that down to a manageable 1 gigabyte per second using a new technology called computational optics, where the compression is happening not in software, but in optics. Strategy number 2 is, if you hear a great idea X, combine it with another idea Y. And the more dissimilar X and Y, more spectacular the fusion. A few years ago, I went for a CT scan. The noise in the machinery kind of rattled me. So I went online and found what it looks like if you actually remove the front panel. And now imagine your head is inside this jet engine. So this technology hasn't changed for the last 30 to 40 years. So there was an aha moment, and I realized space telescopes actually use a coded aperture methods because they want to look at faint stars and cannot build optics for X-rays and gamma rays. So we can actually fuse the technology for CT scans and space telescopes and create a new form of CT machines that have no mechanical motion and remove all the complexity. So in the future, you might be able to create CT scans and volumetric images using headbands and chest bands that are extremely portable. Strategy number 3, given a hammer, find all the nails. If X is a new technique, find all of the problems it can solve. I grew up in Nasik in a family with a very modest income. No TV, no fridge, no eating out. But when I was about 10, my father did give me a cheap black and white camera and 1 roll of film. Now, developing was expensive. So you know how long it took me to take those 24 photos? A week, a month, a whole year. I practiced a lot just composing the shots. Well, I have come a long way from that, and we're building new technology, new cameras that can see a world not 1 million or 1 billion to 1 trillion frames per second. If you shoot a packet of light, a pulse of laser into this bottle, at 1 trillion frames per second, you can see the light in motion. So let's send a pulse through this bottle, and you'll see light in slow motion propagating across this bottle. The light eventually hits the cap of the bottle, starts scattering out. Some of the light is trapped in the air bubbles, meanwhile on the table. And to show this movie, I have slowed it down by a factor of 10 billion. Now, if you take a bullet, which was pretty fast, and send it about for the same distance, about a foot, and again slow down the video by a factor of 10 billion, do you know how long you'll have to sit here to watch that movie? A week, a month, a whole year. And using this amazing hammer of ultra-fast imaging, what nails can we start hitting? We can create new forms of computational photography by using color for time-lapse coding and create these images that show the ripples of waves. Or we can use this ultra-fast camera, this femtophotography, to look around corners. The idea is to send light on visible parts, in this case the door. Part of the light will reflect into the room. A fraction of the light will come back to the door, and tiny fraction back to the camera. And by analyzing these multiple bounces of light, we can see around corners. And this is not just science fiction. We have built this setup and shows demonstration on a tabletop setting. And it'll take us some time before we take this out into the real world. But in the future, we can build cars that can avoid collision with what's around the bend, or look for survivors in hazardous conditions, and use endoscopes that can see deep inside the body beyond line of sight. Sometimes you can use the hammer to hit all the nails, but you can also hit screws and bolts. So think about another example. App Store. We love the idea of App Store. It improves the quality of a phone. Why don't we have every instrument, every device, every gadget that has any computing in it, and make it also an App Store? Your microwave, your fridge, even your car should have its own App Store. Strategy number 4, if X is a nail, find all the hammers. It's an amazing problem that you must solve. Find all the different solutions that nobody has thought about and apply them. And this idea hexagon is not just for technology, but you can imagine also using it for finance, for art, and even for relationships. The next strategy is to think about adding your favorite adjective. And common adjectives everybody uses is making it faster, better, cheaper. But there are more things you can do. You can make it adaptive, distributed, parallelized, and some of the new ones, make it green, democratized, and so on. And finally, you can apply this hexagon. The final vertex is just taking the inverse of what everybody else is doing. Being a teenager, being a rebel, and do exactly opposite of what others are doing. And Fosbury was one of the teenagers. Before Fosbury, in 1960s, for a high jump, you would straddle and land in a sandpit. But when the sandpits were replaced by foam rubber, Fosbury realized that you can actually jump up and land on the back. Kind of a strange way to do a high jump. Long story short, he went on to win the gold medal in 1968, and now everybody uses the Fosbury method. Now, what changed in the ecosystem of an athlete? One tiny thing changed, which is the sandpit was replaced with a foam rubber. And we have to watch out for that foam rubber moment, a tiny change in the huge ecosystem. For me, the foam rubber moment was the announcement of high resolution displays on mobile phones. At 300 plus dots per inch, the pixel pitch of a mobile phone is down to about 25 micrometers. So let's step back and see how diagnostics is done today. If you want to get cataracts, this is how you use a slit lamp, a device that hasn't changed in decades. If you want to do a retinal scan, this is a device that cost $250,000, but check out the user interface. The nurse has to shove my eye into the eyepiece. And to get prescription for eyeglasses, I'm lost in a phoropter. And these technologies are around, but as you can imagine, millions are suffering from conditions that otherwise have simple solutions. So we came up with a new solution called Netra, which is a snap-on eyepiece that goes on top of a cell phone. You look through this lens, align some patterns using the keyboard of the phone, and then at the align, you hit calculate, and it gives you data for prescription of your eyeglasses. And the results are comparable to highest-end instruments. And as a bonus, you can also scan for cataract. And as you know, there are millions who need glasses but are not wearing them. And this is a huge challenge because diagnostics is still very challenging, but providing glasses has become easier and easier. And so what Netra is doing is effectively taking the most complicated instrument, so-called wavefront sensor, and doing exactly opposite of that. It's the X bar. Instead of shining lasers into the eye, it's using the LCD of the screen and the interaction. But with devices like this, children can have a decent shot at education. It's basically a thermometer for an eye. So Netra is being used worldwide. They are moving forward, working with NGOs and government agencies and clinics and designers and technologists to move this forward. And when we saw this woman inventing a new business model by using a weighing scale, I realized that entrepreneurs can take new technologies to the masses in unimaginable ways. Every one of us has intrinsic abilities to invent and solve problems. With a mental framework, every one of us can take new technologies and social innovation to the next level. Thank you.